What if I told you humanity once designed a spacecraft that could reach Mars in just 10 days? Not with some futuristic engine, not with alien technology, but with nuclear bombs. In the 1950s, scientists seriously studied a concept called Project Orion, a spacecraft propelled by a series of nuclear explosions. On paper, it was one of the most powerful space propulsion systems ever imagined. Powerful enough to slash travel time to Mars from months to potentially just days or weeks. So if the idea was real and the physics actually worked, why was it never built? And could we still use something like it today? Stick with me, we will dig in the Project Orion in this video. Before we jump into nuclear-powered spaceships and 10-day missions, let's take a moment and look at the reality of going to Mars as of today. Once you understand how hard it actually is, everything we talk about later will feel a lot more real. Mars isn't just far, it's ridiculously far. At its closest, Mars is about 54 million kilometers away from Earth. Now that already sounds huge, but that's actually the best case scenario. Most of the time, the distance is much larger. In fact, when Earth and Mars are on opposite sides of the Sun, that distance can stretch to over 400 million kilometers. Just to give you some perspective, if you could drive a car to Mars at 100 kilometers per hour without stopping, it would take you hundreds of years to get there. So yeah, not exactly a weekend trip. Now you might be thinking, okay, distance is big, but we have rockets, right? Why not just point one at Mars and go full speed? And that's where things get interesting, because space doesn't work like that. You see, Earth isn't standing still. Mars isn't standing still either. Both planets are constantly moving, orbiting the Sun at high speeds. So if you aim directly at where Mars is right now, by the time you get there, Mars will be somewhere else entirely. It's like trying to throw a ball at a moving train from another moving train. You don't aim where it is, you aim where it's going to be. So instead of going in a straight line, space missions follow a curved path, carefully calculated using orbital mechanics. This path is known as a Hohmann transfer orbit. Now don't worry about the name, the idea is simple. It's basically the most fuel-efficient way to travel between two planets. You accelerate just enough to leave Earth's orbit, coast through space, and then arrive exactly where Mars will be. It's elegant, it's precise, and it saves a huge amount of fuel. But there's a trade-off. It's slow. Even with the most advanced rockets we have today, it takes around 6 to 9 months to reach Mars. Think about that for a second. That's not a short trip. That's almost a year inside a spacecraft, millions of kilometers away from Earth, with no possibility of turning back. Now let me ask you something. What if all of that wasn't a hard limit? What if the 6 to 9 months travel time isn't because Mars is too far, but because of the way we've chosen to travel? Instead of slowly coasting through space, we could actually keep accelerating. Instead of carefully saving fuel, we had a system powerful enough that efficiency wasn't the priority anymore. Because here's something most people don't realize. The reason current missions take so long is not because we can't go faster. It's because we can't afford to go faster with the technology we use today. If you had unlimited energy or a propulsion system powerful enough, you wouldn't need to follow slow transfer orbits. You could take a much more direct path. You could accelerate for a longer time, reach much higher speeds, and cut down the journey dramatically. And this is where things get interesting. Because once you start doing the math, once you start looking at what's physically possible, you realize something surprising. Reaching Mars in weeks is not science fiction. And under the right conditions, even something like 10 days starts entering the realm of possibility. Now I know that sounds completely insane.
What? 10 days?
If you could continuously accelerate for a few days, reach extremely high speeds, and then decelerate as you approach Mars, the total travel time drops dramatically. In fact, with constant acceleration, even at a fraction of Earth's gravity, you could reach speeds that traditional rockets can't even come close to. And here's the crazy part. This isn't a new idea. This was already proposed over 60 years ago. A propulsion system so powerful, so unconventional, that it could turn the idea of a 10-day trip to Mars from impossible to something worth seriously thinking about. So, what was this idea? It was called Project Orion. And to understand Orion, you have to forget everything you know about rockets. Imagine this. You're in space, inside a massive spacecraft. Behind you, a small nuclear bomb is released. It drifts a short distance away, and then it explodes. The explosion creates an enormous shockwave, pushing against a giant metal plate at the back of the spacecraft. And that force pushes the entire ship forward. Then it happens again, and again, and again. Not once, not twice, but thousands of times. That's it. That's the engine. No, seriously, that was the idea. Instead of burning fuel slowly, Orion would use a series of controlled nuclear explosions to generate massive bursts of thrust. Each explosion acting like a giant push, accelerating the spacecraft further and further. It's basically the most extreme version of push it harder and see what happens. Now at first, this sounds completely insane, and to be fair, it kind of is. But here's the surprising part. This wasn't some wild science fiction concept. This was studied in detail by real scientists working on real physics with real engineering calculations. Back in the late 1950s and early 1960s, a team of physicists and engineers came together to explore this idea seriously. Because nuclear explosions release an enormous amount of energy, far more than chemical reactions, which means each pulse could generate an incredible amount of thrust. This wasn't just about going a little faster. This was about unlocking a completely different level of power. A spacecraft that doesn't slowly climb out of Earth's gravity, but instead gets kicked forward again and again, reaching speeds we simply can't achieve today. And if you combine that kind of power with continuous acceleration, you start to understand how something like a 10-day journey to Mars even becomes a conversation. But of course, there's a big difference between an idea and actually making it work. Because controlling nuclear explosions right behind a spacecraft without destroying it, that's not exactly a simple engineering problem. So how do you build something like this? How do you turn repeated nuclear blasts into a controlled, stable propulsion system? That's what we are going to break down in the next video. If you enjoyed this, then please like, subscribe, and turn on notifications so you don't miss part 2.